Hello and welcome back to my RC channel. I'm AndyRC and today I'm going to be doing a build video of the Mode 2 Ghost. This is a frame that is designed by the RC Addict, also known as Seth, also known as Seth PV. I'm sure many of you are subscribed to his channel, and this is an experimental build. It's an amalgamation of all of the information that I've been collecting when doing speed runs. So we have a really lightweight frame. I think it's 55 grams. Let me know in the comments if there are any 5-inch frames that are lighter than that. I couldn't find any, but maybe there are some out there. This is an ultralight, so it's coming in at 212 grams, and there's not a lot I could have done really to get the weight down anymore. The first thing that I did was use the HGLRC F440 stack, so it's a 20 by 20 stack that is designed for a 5-inch model. So we have got 40 amp BL Heli 32 ESCs at the bottom there, and then we've got the Omnibus F4 flight controller with Betaflight on-screen display, and then we've got the VTX, which is the V2, so it's running smart audio. And then you'll see I've got a capacitor installed around here. They say to do that on models that are drawing more amps, and I think that is because to get the size down on these ESCs they remove the capacitors, or should I say they don't put as many on there. So if you're drawing more amps and aren't putting this on a micro, because you could put this on a micro, then they have said to install this capacitor, which they give you in the box. So I've done that, but there are going to be some things in this build that I haven't done before, because even though we don't have current sensors on here again to get the size down, it does have ESC telemetry, so I'm going to show how to hook that up and get that working there. We've got a Runcam micro up the front there. It's the V1 and an XM Plus up here as well, and then at the back we have got a 3D printed Tpu mount. I got this off Thingiverse. It's the one for the XJB145. And then we've got the UXII little antenna there. It connects directly using a UFL. It's a copy, I know, but I got sent it. I should get one of the originals. And it's the one thing that I've changed out actually. Originally I put the SMA connector on there because I was worried about this getting stripped off, but then I found this mount and I managed to save some more weight. But yes, in the build video you will see me have a SMA connector coming out the back there. That's the only thing I've changed after the build video. So another way that I have gotten this really light, and as I say this is experimental and I may change it, is the motors. They are the Hyperlite 2204 3022 kV. Now this motor is designed for a 4-inch blade really, so I could just plug this in and fly it and the whole thing explodes. I don't know, but I can't ignore the fact that these motors only weigh 23 grams. If you compare that to something like a 2207 or a 2307, those are coming in at 31 to 34 grams. It is a huge saving, and I'm still retaining the 2.2 stator size. You see, you can go lighter than this. You can put a 1407 motor on there with high kV. And from the videos I've seen, what happens is there's just not enough torque there for the 5-inch blade, and what happens is you throttle up and it takes some time for the motors to spool the prop up because there's not enough torque there. So I thought if I went for the 2.2 stator size and then put a lightweight prop on and then high in kV, I might be able to see if I can go really fast. That is the idea. I think my floss, it goes about 117 mile per hour. I think it was at 115. I can't remember. But I'm hoping that I can maybe match that, or maybe it won't. Maybe it'll be slower. That's why it's an experiment. But yeah, I'm pretty excited to try it. There's a funny story about these props as well. So you might have noticed that there haven't been any videos on the channel for a fair few days, and that is because I was doing this build and I bought these propellers off eBay, and they sent just completely different ones. And I went on the Let's Drone Out podcast on Thursday, and I complained about it, and one of the listeners heard about my problem and knew that I was going to Mini Air Show on Saturday, and he handed me these props. So thank you to Luke, also known as Falling With Style FPV. I can now carry on with this video. They're the dowel prop. They are the T5051C, so they're a really lightweight propeller. You can see they're really skinny, and they only weigh 3.3 grams, so they're very lightweight. Again, I've gone for the lightweight, so hopefully this high kV motor can still spin it. That's the hope, but they're quite high on the pitch, you know, with 51 there, so it still could struggle, and it could draw too many amps for the system, you know, so it's all an experiment at this point. But yeah, this motor is fantastic. It's just so thin there, but you know, that could cause a problem, but we'll see. We've got the naked bottom there, just a really good quality motor, and this was a happy accident. The colour of the bow here, it matches the colour of these standoffs here. While I'm here, I want to mention about the frame. I think the frame actually I prefer than the Floss one, because you can access the arms without having to remove the standoffs for the stack. With the Floss, it's connected, so if you break an arm, all of this has to come off. Not so with this one. It's a really nice, simple and cheap. I paid £35 for it, so I think that is a good deal. I did have to add a battery strap and a silicon pad underneath there, otherwise it will throw a battery. So starting off with the battery connector, I've taken some 14 gauge wire, cut it to length, and now I'm tinning up the negative and now the positive. And this is the XT60 connector being tinned up, that's the positive. And then the negative, this is a Hakko premium soldering iron. Now I'm soldering in the positive wire there, and then the negative. I'm then going to take some of my own heat shrink and put that over the top. Then I have this mini heat gun, so I'm going to shrink that down for both of the wires. I'm then going to tin up the solder pads on the 4-in-1 ESC board, so that's for the battery connector there, and then this is for the individual motor wires, so I'll speed that up so you don't have to watch it in slow motion. And then I'm going to solder in the negative of the battery connector and then the positive. I know I'm not using helping hands, they slow the video process down. So now I'm taking one of the bolts and I'm going to assemble the frame. It's so easy to assemble. I wasn't sure if I was going to show it, but it didn't take long. So we have these standoffs that go over the top of the arms there, and then these nuts that go over, and that's two standoffs in, and then the front arms are exactly the same. And then I used a socket set just to tighten those nuts up, just about get that in there, no problem. So now I'm weighing up the motors because I wasn't sure which I was going to use. Look at that, 23 grams for the 2204, and if all else fails it's going to be this one. That's 32 grams, that's the 2207 Team Edition 2700 kV. But yeah, I'm using all of the screws here and screwing in the 2204 motors. It's going to be an experiment, like I say, so that's all of those have gone in there. So this is the standoff for the HGLRC F440 stack. It's actually a metal screw and then a nylon standoff, so that's all of those that have gone in there. Then I'm going to put a battery strap in there and fit the board over the top. It's my own battery strap. And then I'm going to cut the motor wires to length, and I was a little bit more accurate this time because, like I said, I was trying to save as much weight as possible, so yeah, just a little bit of slack, but yeah, I was cutting them very close there. And then I use my wire stripping tool to strip all of the wires, so I'll speed that up. And then I'm going to tin up all of those wires as well, so I'll speed that up as well. Lots of tinning, cutting and stripping in this video, but that's how we build these models. So next I'm soldering the motor wires straight, and if you do it correctly then all of the motors should turn the correct way out of the box. Of course you can use BL Heli Suite to go in there and change it if you get it wrong, but on this rare occasion I got it right, so they were all spinning the right direction. So yeah, just soldering the last ones in there, nice silicon wires, I always like to see that. And then this is the wire for the ESC telemetry, so I just cut my own piece of silicon wire there and leaving that for later. So now I'm going to tin up all the solder pads on the F4 board. It's quite fiddly, and yes, I know I could use helping hands, but it takes much longer to edit the videos and even film them as well, you know. Talking about a week's worth of work for this entire video. So yeah, these are the TX and the RX pads underneath. So just tinning up that RX pad now, and I think it is RX6 that goes in there, and then this is TX3 for the smart audio. And then I've taken one of my own buzzers and I'm just going to slot that through the holes there. It fits quite nicely. Do have to bend it round a little bit, but I'm going to solder that in there. And then I'm going to put some more of the nylon standoffs over the top so the flight controller can fit over the top. It just sits on some pins, so you have to be careful that it all lines up. Next I'm assembling the 3D printed mount for the camera. It's just 2 screws, and yeah, this is the Runcam micro. Then I'm cutting the wire to length there, and then I'm gonna strip all of those wires. And yeah, this is for plugging into the flight controller. So yeah, tinning those up now. So that's the ground going in there, and then that's the video in. And then that is the 5 volt, and then I'm going to use another section of this wire and I'm going to tin that up, and then this is going to be for the VTX, so that's the ground to the VTX, and then that is going to be the signal for the VTX, and then that's VBAT. So this is the video going into the VTX, so real miniature soldering there, and then this is the ground. So sometimes I find that if you sort of bend the wire over it works okay. Then I'm going to solder that ground wire down and then do the same with the VBAT, so feed it through and bend it over and then solder over the top. And then the last one is the smart audio, so once again bend it over and then solder over the top. And then I'm going to use another section of this camera wire, and this is going to be for the receiver. So again, just tinning both sides up there, and that's the 5 volt going in, and then the ground, and then the signal for the S-bus. Then I'm going to take an XM Plus and just tin up the pads there. And then in goes the S-bus wire, and then the 5 volt, and then the ground. Then I'm grabbing some heat shrink. They stopped giving you heat shrink with these XM Plus. It's really annoying, so it's my own heat shrink, and then the heat gun again. And then these are the standoffs for the VTX to sit on, so just screw those in by hand, and then VTX goes over the top, and you got some little tiny nuts for that to go in. Then I'm plugging the camera in now, and then pushing the mount over the standoffs, and then this is the SMA connector, which I didn't use in the end, but you can see there that it just sort of wraps around and plugs in. It's my own SMA connector. Then I'm using some 3M sticky tape just to plug in the receiver. This receiver is flashed with the RSSI on channel 8. Now I'm tinning up the capacitor, so I've just lengthened the wire a little bit, and then I'm tinning up the pads on the board as well, because I did this last, I wasn't sure where it was going to fit, but it fits nicely behind the camera. So that's the negative that's gone in there, and then the positive, and then that just wraps around there and fits in there snug. So I'm feeding the antennas through to the top for my receiver, and then I'm going to screw down the top plate. So there is 4 screws for that. And yeah, I'm not fully tightening them up at the moment in case I need to take the top off, which I actually did, because that secures the arms in as well. It stops the arms moving. And then I'm cutting my own silicon mat, and that's just to stop the battery from throwing in the air. So that's 2 of those on there. Then I'm using some cable ties just for my antennas. And then I've got my own heat shrink, and I just put that over the top as well. And once again, get the heat gun on it. It's quite handy, this heat gun. It's a butane one, so it's just like a glorified lighter. And I'm putting another battery strap around here as well, but I don't know if I'm going to use it. And then some electrical tape here just to neaten up the wires, but they're pretty neat in the first place. Could have saved some weight there really, couldn't I? But never mind. Every gram counts in this build. So just wrapping that round there, and then cutting it off with some scissors. And that is the build complete. Okay, so I'll show you how I've got my Taranis set up. So if I press menu and page over, I've got the model name as mode 2. And then I've got the failsafe set to no pulses. As this is an XM Plus, we're in D16 mode, and channels 1 to 8 for the lowest latency. And then at this point you bind the model, so plug your battery in whilst holding down the bind button on the receiver. Make sure your antenna is on for your VTX, and you'll get an option here that will say telemetry, and as this is an XM Plus, just go with telemetry off. You'll have less issues. And then if we page over to the mixer, so for channel 5 I have got set as ARM, and I've set this 2-position switch here. And then if we go down, next one I've got as mode, so I'm going to have angle and acro and air, and you can see that's that switch there. And if I just go down one further and edit, so channel 7 I've got set as buzzer, and that is on this 3-position switch, and that's all I do for my setup. Okay, so here we are in the Betaflight configurator. I've got the props off the quadcopter. I've got it plugged into the computer just via the USB, so the battery isn't plugged in yet, and I've updated it to the latest version of Betaflight. So let's connect. I'm in expert mode. Let's check out the ports. So I've got the serial RX on the UART1 for the S-Bus receiver, and then on the UART3 we have got IRC Tramp for smart audio, and we have got sensor input as ESC. So if I go into configuration, now this should support D-Shot 1200, but when I do my maidens I usually go for 600 first, because sometimes 1200 can cause some problems, so I'm sticking with that. And I have also set the motor idle at 6. That might be a little bit high with this being a lightweight model. I will see. So if we scroll down here, I've got my arm angle at 180 in case I get stuck in a tree or something like that. I've got the accelerometer turned on because I like to do my maidens in angle mode, and also have angle mode there as a safety switch. If maybe I lose video, I can lift the goggles up and then flick it into angle mode and it will right itself for me. So I have got the PID, loop frequency, and gyro update frequency at 4K, 4K. I've got personalization as mode 2, that's for the on-screen display. The receiver, we have got serial based receiver and then S-bus down here, and then I've got dynamic filter turned on, anti-gravity and ESC sensor, and then on-screen display and air mode. And I haven't got LED strip on there because there isn't one, but it's important to turn on ESC sensor if you want that information. Of course, there's no current sensor on this, so we're not able to use that. Just a couple of things that we can take from it, and I've got the USB turned off there for the buzzer as well. So if we go into power and battery, you can see I tried to see if it had a current sensor on the ESC, but it doesn't, so that's not doing anything. But we do have onboard ADC for the voltage meter, so I can keep that on there. I've got the minimum cell voltage at 3 because I want to use my on-screen display to tell me when I should land rather than my beeper, and the same for the other warning. And then I've got my maximum cell voltage at 4.6 if I want to use a high volt. So fail-safe, you know, I haven't touched anything here, it's just set at standard, and I've checked it and it works, you know, so just make sure your props are off. Plug the battery into the copter, arm it, turn off your transmitter, and the motors should stop. And I don't usually have to do any work for that. Right, so this was just stock PIDs in here. I have just put a guess PID in here. I have no idea what this is going to do with it being lightweight and a strange combination, so I've gone with this. I've got my super rate at 0.8. Actually, I like to go up to 1000s, so I'll go 0.81. We'll just change that. And then got my anti-gravity gain at 3 and my TPA at 20, so I'll just save that there. Then if we go into the receiver tab, nothing will show up because I don't have my Taranis turned on, so I'll just turn that on and then plug the battery in. I've set the VTX at 25 milliwatt, and you can see there that I'm getting my RSSI on here, and I have got all of my controls here, and I've put a little bit of RC deadband in here as well. And I don't usually touch the low stick threshold or the high stick because I tend to find that the stock values are absolutely fine for me. But yeah, as you can see, aux4 there for my RSSI. So yeah, I think I did a video where I called it How I Review a Quadcopter, and I showed how to flash the version of the firmware with the RSSI on channel 8, so you can go and watch that video. But yeah, we've got TAER for the channel map there. So for the modes, I've got arming on the aux1 there, and then we've got angle over here, and then it will be acro and air over here, and then just the beeper on the aux3, so I can show you all of that working there. And I can just see if my modes are working as well. It won't arm because it's plugged into the computer, but if I unplug it from the computer it will be fine. So I don't do anything in adjustments, and I don't do anything with the filters either on the first flight. The motors you're going to want to check are spinning in this direction here, and I've already checked that mine are. On-screen display, so we have got the ESC RPM and ESC temperature. I've got those at the top there, and just my voltage over here, my mode, and my VTX channel I find really useful, and the flight time as well. And I got some stuff disabled down there as well. So that's pretty much everything there. I'll just show you the version because it changes all of the time. So target is Omnibus F4 and it's 3.32. So now if I disconnect from this, and then if you did need to change the motor direction, we've got BL Halley Suite 32, so you're going to want to have clean flight. selected there, and make sure that we have got the COM port selected. Sometimes it doesn't like it when you come straight out of beta flight, so sometimes it doesn't connect, but it looks like it has done there. So if we press check on here, there we go, you can see. So yeah, if you wanted to change any of your motor direction or any settings, then you could do it here. I am just going to leave everything stock for now, and that is the setup. Well, I'd be lying if I said I wasn't nervous. Just in angle mode here, just to check that flies okay. Look at this, we got the sun out and everything seems to be okay. So let's see what the punch is like. Well, I blinked and it disappeared, so I think it's got a fair amount of punch. It seems to be instant as well, so maybe that 1000 milliamp battery helping there. Yeah, not hearing any oscillations either, so that's good. Okay, let's try acro. Feels very floaty. To try and not go in the shade, otherwise the camera won't pick it up very well. Always something to complain about, eh? So really, the main objective of this line of sight flight is to just ensure that it doesn't explode. And so far it's okay. I love it when I say that, because that's usually when it explodes. The wind is pushing it back as well. But yeah, I think this initial tune I've put on it's okay. One of the things I'm worried about with these props is them deflecting, basically bending under the high RPM. But you know, it's fairly quiet. Oh, that wind is pushing it back today though. To be careful actually in angle mode. If you haven't got enough angle on there, then the wind can push it back, and you haven't got enough to get it back. But yeah, so far it's behaving. Yeah, I'm not seeing any initial torque issues. However, sometimes it's difficult to see on the line of sight. I've had that with copters before. But, you know, it's not falling out the sky. And the tune doesn't seem too bad. I'll probably have to tinker with it, especially if I stick a 1300 on here. The problem is I've only got one 1000 milliamp battery. So I'll have to keep charging this one or use a 1300 and probably have to change the tune for that. That's what happens when you start messing with weights. Usually a heavier copter doesn't make much of a difference when you add a little bit more weight, but a lightweight one, you have to change the tune. Well, it hasn't exploded, so let's bring it in for a landing. So this is actually the FPV Maiden, so I thought I'd throw it around a little bit to see how it flew, and it flew very nice. And I'll give you my final PID tune as well, because that worked well. Really like this stack, nice clean video, but let's check out the speed. Oh dear, only 87 miles per hour. So it's either the case that these motors cannot provide the amount of torque required to get this prop spinning at those high RPMs, or it's the 1000 milliamp hour battery that is not able to provide enough amps, and we're actually getting some sag. Now I can actually check that. I can switch it out for a Tpu R-Line 1300 milliamp. So I'm going to do that, but yeah, disappointing results. Let's check out the RPM there. So yeah, 19,000, 20,000 RPM in the corner. So this is the 1300 milliamp Tpu R-Line 4S, so higher capacity. So let's see what the speed is this time. So faster, 97 mile per hour. It's not what I was hoping for, though. The Hawk 5 does 106 mile per hour out of the box, and hey, it looks like it's easier to get these 3-inch models much faster. I mean, the S140 is like 112 mile per hour, and you know, I've spent loads of time on this and going lightweight, and it's slower. And this was actually the fastest speed it recorded on these props, 101 mile per hour. So yeah, I was hoping for about 115, but not the case. I did spend all day trying different prop pitches, and it was actually this prop that gave the fastest speed. So lower pitch props didn't help at all. In fact, it was much slower, about 80 mile per hour. So yeah, there you go. I really like the HGLRC Stack though, but I'm going to have to try those 2207 more torquey motors. So if you enjoyed this video, I think it took about a week and a half to make. So if you can afford to do so, then I will link to my Patreon in the below, and I'd really appreciate if you could donate to that. And I'll also link to all of the parts used in this build. And as always, thanks so much for watching. Please continue to subscribe. Cheers.